we would like to show that the function f of z equals z bar, the complex conjugate function, is nowhere differentiable. So for this, we will use the alternative form of the derivative. F prime of z is the limit as h approaches 0 of f of z plus h minus f of z divided by h. And here h goes to 0, that's the complex number 0. And so h can go to 0 along any path in the complex plane. And we're going to show that this limit does not exist because we're going to choose, by choosing two paths that give different limits. And since in order for the limit to exist, all paths have to give the same limit, that will mean the limit does not exist. So, okay, let's just continue from here. Our function is the conjugate, so f of z plus h is z plus h quantity conjugate, and then minus f of z is z conjugate, and we're dividing by h. And now this becomes, we'll use the property of the conjugate. The conjugate of a sum is the sum of the conjugates, and we'll use that right away. So z bar plus h bar minus z bar, okay, those will cancel, and we just get simply the limit as h goes to 0 of h bar divided by h. And h bar divided by h is a very simple quantity if h is real. If h is real, then this equals just 1, because the conjugate of a number is itself. And if h is purely imaginary, like if it's I, then it's its negative. And so this is negative 1. And so those are two of the possible limits we can get here, and they're different. And so this limit does not exist. So again, in maybe a little more detail, if we consider case 1, h is real, so h is going to 0 and h is real. So the picture here is 0, h is a real number, h going to 0 like that. Then this limit, h bar is just h, and h over h is 1. And so then the limit of 1 is 1. And in case 2, h is imaginary. So h is going to 0 on the imaginary axis. So h is equal to something like ik, where k is real and heading to 0. But I don't think we're going to write that. So this is the limit as h goes to 0 of h bar divided by h. And if h is a purely imaginary number like this, then its conjugate is negative ik, which is negative h. So this is the limit as h approaches 0 of negative h over h, and that ratio is negative 1. The limit of negative 1 is negative 1. So then finally, since negative 1 does not equal 1, this limit does not exist. And so therefore, there's no derivative for the function, and the function is not differentiable. And it didn't matter what z we chose. This is true for any complex number z. As we can see right in the beginning, the z actually cancels out. And we're just left with the limit of h. Okay.